a squared
Sine
equals
A
b squared.
over
Area of the triangle
A
equals
equals
half
B
AB sine c. You are given these three formulae in your formula sheet for GCSE Maths, but for A-level you're expected to remember them. Regardless of if you're doing A-level or GCSE Maths, it can be useful to understand where these formulae come from. Hello, and welcome to this video in which we're going to derive the cosine rule, the sine rule, and find a neat expression to work out the area of a triangle. For GCSE Maths, you aren't required to memorise these equations, although you should be comfortable with using them, but for A-level Maths you're expected to know them. Once again, before we get started, make sure you check out mathsquared.org for further resources. Imagine we have an ordinary triangle. It can be any triangle with angles A, B and C, with sides lowercase a, b and c. We can start by drawing a line straight down from C, such that we create two right-angled triangles. We'll call the point where this line meets C big X, and the distance between A and big X will be little x. We can then work out what the distance will be between big X and B. You should be able to see that this distance will be equal to C minus X. Now that we've made two right-angled triangles, we can start to consider some trigonometry. We'll also define this line from C to X to have a length h. We can focus on triangle AXC first. We can use Pythagoras' theorem to write that x squared plus h squared equals b squared. We can then shift our focus to triangle CXB and say that c minus x squared plus h squared equals a squared. We can manipulate these equations as we would have done when we dealt with simultaneous equations. If we take equation 2 away from equation 1, we will get x squared minus c minus x squared. The h squareds would cancel out, and this would leave us with b squared minus a squared. With our new expression, we can expand the brackets to give us c squared minus 2xc plus x squared. Of course, remember we're taking this away, so each term will be times by minus 1. We can also cancel out the x squareds, since we've got an x squared and a minus x squared. We can now go back to our triangle. Let's look at triangle AXC again. If we take the cosine of angle A, what would it be equal to? Well, as cosine is the adjacent over the hypotenuse, and our adjacent is x and our hypotenuse is b, we can write that cosine of A equals x over b. Rearranging gives x equal to b times cos A. We can now take this and substitute it into our equation for x, to finally give this expression here. And finally we can rearrange this to get a squared equals b squared plus c squared minus 2bc cos A. This is the cosine rule. Let's derive the sine rule. We'll start with this scalene triangle. Once again, we'll draw our line down from C, which has a length of h, to create two right-angled triangles. We'll then consider each right-angled triangle separately. Looking at the first triangle, we can write an expression for sine of A. Now, as sine is equal to the opposite over the hypotenuse, we can say that it will be equal to h over b. We can rearrange this to make h the subject. Now we can do the same process for the second triangle to get an expression for sine b. Again, sine is equal to the opposite over the hypotenuse, so sine of b will be equal to h over a. Rearranging to make h the subject, we get the following. Now we have two expressions for h and we can set them equal to one another. And finally we can divide both sides by ab to get that sine a over a equals sine b over b, otherwise known as the sine rule. Finally, we can derive an expression for the area of any triangle. We can draw a dotted line down from A, creating two right-angled triangles. You may remember that the area of a triangle is equal to half times base times height, and the base is A and the height is h. Now if we consider this second right-angled triangle, we can write an expression for sine of C. As sine is equal to the opposite over the hypotenuse, we could say that sine C equals h over b. Rearranging and making h the subject, we get that h equals b sine C. Subbing this into our area equation, we get the following formula. The area of any triangle is equal to half AB sine C.